I'm not sure people naturally associate new parasites with climate change, but it's likely that their changing ranges are another symptom of it in the north.
Hi, I'm Emily Chenery. I'm a PhD student here at University of Toronto, where I'm researching the spread and impact of the winter tick parasite into Yukon territories.
Winter ticks go from egg to adult in just 1 year, feeding on the blood of a single host animal for most of their life. So that's normally a big deer like moose, elk, or caribou. Elsewhere in North America, winter tick are well known for becoming hyperabundant. That is 50 to 60,000 individual ticks on a single moose, which can often lead to hair loss, blood loss, and fatality. We don't really know a lot about winter ticks in the north, so this field season's really been about just trying to collect as much information as possible.
I'm trying to piece together these little bits of information that we do have right now, as well as collecting more in the field, in the lab, and through using mathematical modelling techniques to see if we can work out what is going on in Yukon right now, where are the ticks, and what kind of impacts could they be having in the future on these culturally and ecologically important species like moose and caribou.
This lack of data is what makes my research so challenging, but it's also what makes it really exciting. This fellowship gave me so much more than just camera traps or sampling equipment. It gave me opportunities, mentorship, just all the support that I needed to be up there in Yukon. And I think that's the most important thing moving forward, actually talking to the people for whom this research matters the most.
I'd really like to thank the many people that made this research possible, particularly the Garfield Weston Foundation and WCS Canada for the fellowship funding that allowed me to go up to Yukon for 3 months this season to find those ticks.
Finding the larvae was an important first step in understanding how and why these ticks are moving north.
Today we found a second detection, and I made the decision that we were going to prioritise south-facing slopes with a very specific low vegetation and dry habitat. And we just found them again. So it looks like our hypothesis is right, and we might be getting a bit closer to finding out exactly where in Yukon they're surviving and where the hotspots are for collection.
So this is the first time that larvae were actually detected this way in Yukon, which is really, really helpful for designing next year's sampling strategy. We knew that they were here because the adult ticks had been found on the hides of dead animals submitted to the government. I'm actually now working with a government partner to try and improve the technique for looking for these ticks so that we can detect this tiny life stage on there too. That'll help us just know where these ticks are early in the season. Site access is probably one of the most challenging things that I experienced this season, but you know what? You get rewarded with some pretty amazing views. Some other problems, such as the weather changing when you weren't expecting it to.
Emily Chenery, October 10th in the Yukon, mounting her camera traps in about, 20 centimeters of snow.
Oh, yep.
Snow everywhere.
So much fun.
In all, I installed almost 60 wildlife cameras, so these are going to be looking for tick-induced hair loss on host animals over the winter. I'm really looking forward to seeing what we find when I collect them again in May, as it should give us an indication of the current level of winter tick impact, particularly on moose. It's such a privilege to work in this part of the world. The Northern Boreal Mountains are home to an array of life that reminded me every day that it's such a special place with so much worth protecting.